this problem has quite a few traps. I was trapped. I thought I avoided some traps, but there was one that I ignored. Let's read the problem. 22 people, and we know that some of them wear sunglasses, some of them wear caps. And if we look at sunglasses, between 70% and 80% wear sunglasses. And between 55% and 60% wear caps. Little m is the smallest possible number of both, and a big M is the largest possible number of both. We want to know the difference between big M, and the little m. Okay, so the first trap is that, so if you first work on percentages, then at the end, in the last step, you multiply the result by 202, the answer will be wrong. This is because we are dealing with a human subject case. The number of subjects of this or that should be an integer. It shouldn't be a decimal or fraction, so we should only consider integers. Because of that, we need first to convert the percentages to integers. If we don't do that by the end, maybe in the middle, we use the decimal number of people, then that's not correct, okay? So let's convert the percentages to integers. So the first one, we have a 151.5. And 202 times 80%, we have 161.6. And 202 times 55%, we have 111.1. 202 times 60%, we have 121.2. Okay, so you might think, okay, this is easy. I know how to convert them to integers, 151, 161, 111, 121. But that is incorrect. We see that for sunglasses, it's between 75% and 80%, which means that it should be greater than, no less than 75%. If we floored 151.5 to 151, that percentage is going to be less than 75%. So we have to use the ceiling function. So we convert 151.5 to 152. And for 161.6, for this one, if we round it to 161, it's going to be less than 80%, that's fine. But if we make it 162, it's going to be more than 80%, which is not okay, because we know that the sunglasses is between 75% and 80%. So the upper boundary for sunglasses is 161. You see that for the two numbers, for the 151.5, we use the ceiling function. For 161.6, we use the flooring function because the numbers is between 75% and 80%. So this is for sunglasses. And similarly for caps, the lower boundary is not 111, it has to be 112. The upper boundary is 121. Okay, so little m is the smallest possible number of people with both. Then we need to look at the lower boundaries, which gives us the minimum number of sunglasses and the minimum number of caps. And from problems in previous weeks, you already understand that the smallest possible number with both is 152 plus 112 minus 202. This is the smallest overlap between these two if you draw a diagram, a Venn diagram. I'm assuming that you already know how to do that, so I'm skipping. This is 62, which is little m, the smallest possible number with both. And for the big M, the largest possible number, we want to use the maximum number of people with sunglasses and the maximum number of people with the caps. We see that if we let every people with caps also have sunglasses, then we have the largest possible people with both. So this is M. The difference is 121 minus 62, which is 59. So there are quite a few traps. I hope you learned some tricks. Sometimes, for the routine strategy, for example, a lot of time we want to simplify things at the end, but for this problem, we cannot do that. This is because the number of subject is of this or that has to be an integer. Problem 16. There are 5 students with 3 girls, 2 boys. Their names do not indicate their gender. We also know that two wear white shirts, 2 white shirts, 3 black shirts. Nikin and Carrie wear different color shirts, which means that one wears black, the other wears white, right? Barry and Jamie wear the same color shirt. Which color can it be? Can it be white? If both are white, and recall that among Mickey and Carrie, at least one is also white. Then it will be 3 white. That is not possible, which means that for Barry and Jamie, it has to be black, right? They wear black. Next, Peter and Carrie are the same gender. We don't know what. Jamie and Megan are different gender, which means that among Jamie and Megan, one is boy, one is girl, right? Now let's go back to the previous statement, which says Peter and Carrie are the same gender. If both of them are boys, then among Jamie and Mickey, there's another boy. Altogether, there would be 3 boys. That's not possible, which means that both Peter and Carrie are girls. So both of them are girls. Okay, we are looking for the boy wears the white shirt. And we already know 2 people wear black and 2 people are girls. So we can rule out those names. So Barry wears black, Jamie wears black, Peter is a girl, and Carrie is girl. So the only remaining choice is D. Problem 17. For how many positive integers x is this ratio an integer? We don't care about what this value is. We know that it has to be an integer. And this is a ratio. We see that both the numerator and the denominator involves x. That makes things complicated, right? So if we could get rid of 1x, that would be great. Because we only care about whether it's an integer, so we can rewrite things. For the numerator, we can try to take out the part that would give us integer. We see that the denominator is x plus y. So for the numerator, we find x plus y and the remaining one. This gives us 1 plus 72 over x plus 1, right? As long as 72 over x plus 1 is an integer, then the whole thing is an integer, right? Okay, we also notice that x has to be a positive integer. If we look at 72, if we do prime factorization, it equals 2 to the power of 3 times 3 to the power of 2. We know that it has 4 times 3. It has 3 plus 1 times the 2 plus 1 number of factors, which is 12 factors, right? So the factors goes from 1 to 72. But recall that x plus 1 cannot be 1 because x has to be positive, because x is positive. So the 1 doesn't work. The rest of numbers work. So the total number is 11 numbers. Problem 18. A list of integers are written on the blackboard, including the number 2020. The sum of all these integers is also 2020. The product of these integers is also 2020. What is the following? Which of the following could be the number of integers written on the blackboard? We know that 2020 is one of the numbers, and the product is also 2020, but all of them are integers, which means that the rest of the integers, they have to be just a 1 or -1, right? So the list of numbers, they could be some 1s, some -1s. We don't know how many of them. Let's do ... Then we have 1, 20, 20, right? Okay, we see that the product is 2020, which means that the number of -1s should be even. There should be even number of -1s. And the sum is 2020, which means that we have the same number of negatives and the same number of positives. So this is an even number, and this one is also even number, which means that we should have a 4. The number of the -1s and the 1s in total should be a multiple of 4, right? So it should be 4k and then plus 1, right? So this one comes from 2020. So altogether, we should have 4k plus 1. If you look at A, B, C, D, D is the only choice. D is the only number that can be written into 4k plus 1, or if you subtract 1, D is, after subtracting 1, D is the only one that is divisible by 4 after subtracting 1. Problem 19. A book has n pages. The first page has page number 1, and if we look at all the page numbers, the total number of digits is 6,869. What is the sum of the digits of n? So if we look at pages 1 through 9, each of them has 1 digit, right? So it's 9 times 1, which is 9. If we look at between 10 and 99, we have 90 pages, and each of them has 2 digits. So this is 180 digits. Starting from 100 to 999, each page has 3 digits, and altogether we have 900 pages. The number of digits is 2700. Okay, let's see what we have so far. We have 98829. How many more do we need? 6869 minus 2889 0893. And notice that in the next group, each page has 4 digits starting from 1000. And how many pages do we need? Each page has 4 digits. 3980 divided by 4. 995. We need 995 pages. Each has 4 digits. That would give us 3980, right? So starting from 1000, we need until page 1994. Thus, n is 1994. We are looking at the sum of the digits, which is 1 plus 9 plus 9 plus 4, which is 23. Problem 20. ABCD is parallelogram. We have some points. We have a BE is 5. We have EF is 2. And we want to know FG, right? We see that there are many similar triangles. For example, this one, FDG, and the larger one, BCG, they're similar because FD and BC are parallel with each other, which tells us that FG over the longer, the side of the corresponding, the larger one, that is 7 plus FG, is the same as FD over BC, right? And FD equals AD minus AF over BC. And this is parallelogram, which means that AD and BC are the same. So it's BC minus AF over BC, which is 1 minus AF over BC. Okay, if you look at AF over BC, that ratio can be obtained by the two similar triangles, AEF and BEC. That ratio is 2 over 5, which is the same as the EF over BE, right? Okay, so now we have FG over 7 plus FG equals 3F5. We solve for FG, so this is 5 times FG equals 3 times 7, 21, plus 3 times FG, which means 2 times FG is 21, which means FG is 10.5, which is the answer.